So I have a problem. Well, I had a problem until I made this. These parts save me over 5 minutes every single day. In fact, I love them so much, I smile every time I use them. Let me be clear about one thing. There were probably way easier ways to solve this problem. But to understand why I went this route, there's something really important you need to know. About 10 years ago, I was doing some room renovations and I figured it would make sense to add speakers and volume controls while I had the walls open. And this worked out great, at least at first. As I renovated, I added more speakers and volume controls throughout the house. But this created a really big problem. And so began my nightly routine of going from room to room, turning off all the volume controls throughout the entire house. Of course I have speakers in my bathroom. I spend a lot of time in there. But seriously, there has to be a better way to deal with this volume problem. Time to get a little bit nerdy. So here they are, 10 beautiful, wirelessly controlled channels of volume-changing bliss. The result of countless hours of design, coding, 3D printing, and assembly. But before we play with them, let's talk a little bit about their design and how they work. I started by making a list of project parameters to make sure my new solution didn't just leave me with more problems. The first, and really the most important constraint, was that the new system must work with all phones and tablets. I want to be able to sit on my butt and use Wi-Fi to control the volume in any room in my house from my cell phone, or my tablet, or my laptop. The second constraint I established was that the speakers must use the existing in-wall wiring. There is absolutely no way I would use 10 sets of Wi-Fi speakers for this project. It is a terrible idea. Wait, you just said you wanted to use Wi-Fi. Now you're saying it's a bad idea? There's a huge difference between sending 1 kilobyte of data to change a volume position versus the more than 10 million kilobytes it would take to stream music all day. As a visual reference, this bar graph shows just that. And here's why that's relevant. Wi-Fi uses electromagnetic waves to send and receive information, as do TV and radio broadcasts, but you'll notice the waves are closer together with Wi-Fi, and even closer together with satellite. The sun also gives off electromagnetic waves, but these are the only ones humans can see with our eyes. And then there's even higher frequencies such as X-rays and gamma rays. So of all the frequencies available, Wi-Fi is only capable of using this small, narrow band of frequencies. So we could say that Wi-Fi is kind of like a highway. Even with a limited number of lanes, vehicles can usually drive at the posted speed limit. But as you increase the number of cars on the road, you'll find yourself in traffic and have to drive at slower speeds. I really just don't want all that network traffic, and that's why this project will stay hardwired. The third constraint is that the project must be cost effective. I'm not looking to spend thousands of dollars on a store-bought system when I can build it myself for cheaper and have a bunch of fun along the way. Then a light bulb sort of went off in my head. You see, about 20 years ago, I built a modern computer-based wooden jukebox. You can see the computer motherboard mounted as part of the visual display of the jukebox, as well as all the cool, glowing computer lights and screen. Aesthetically, I thought it would be fun to change it up though, so I decided to incorporate the new volume controls into the appearance of the jukebox. With that in mind, a fourth constraint was added to my design parameters. That is, that the solution must have an aesthetic appeal since it's going to be a focal point inside my jukebox. So here's the plan. I want to control the volume of all 10 rooms from any cell phone, so I'll write an app which gives me volume sliders for each room. The app will need to control the position of each volume knob, so I'll attach a servo motor to each volume control. The servo is a small device commonly used in RC cars to steer the vehicle. They can be turned to very precise positions, so they should be perfect for this job. I'll then add some pulleys and a belt to connect the servo to the volume controller. One last piece of the puzzle. Cell phones can't communicate directly with servos, so I'm going to need some type of microcontroller that can talk to both the cell phone and the servo. For that, I plan to use a tiny, affordable microcomputer called a Raspberry Pi. This tiny computer has built-in Wi-Fi so it can communicate with the app on my phone, HDMI so I can use a monitor or screen if I want to, as well as pins that can be used to communicate with external devices such as servos. With the design in place, it was time to get started with some CAD so I could start making the necessary parts to start assembly. I drew 3D models of the volume controller and servo so I could model the support brackets, pulleys, and other parts needed to make the assembly function. I started with the bracket that holds the servo to the volume controller. Finding the perfect balance of strength versus aesthetics was a little tricky because I wanted to keep the bracket as slim and small as possible. The problem is that there's a lot more force on this little bracket than you might expect. A quick measurement showed me that it takes roughly 3 pounds of pulling force to maintain proper belt tension. Without enough tension, the belt would slip on the pulleys. So if you think about Newton's third law, he stated that for every action, there's an equal and opposite reaction. Meaning that if the bracket is pulling with 3 pounds of force on the belt, then the belt is also trying to bend the bracket with 3 pounds of force. When I apply that force to my bracket, you can clearly see it isn't strong enough. In the end, I used stainless steel welding rod to reinforce the bracket, which made the bracket super solid, and it has almost zero deflection even while maintaining over 3 pounds of belt tension. The only other physical hurdle that I needed to overcome was fairly simple. I needed to figure out what diameter pulleys would work together. Most hobby servos have a range somewhere around 180 degrees, but my volume controls needed to rotate a full 330 degrees. This means a simple ratio of 2 to 1 would work because we know that pulley ratio can be derived by using the formula drive pulley diameter divided by the driven pulley diameter. I arbitrarily chose 0.6 inches for the diameter of the small pulley, so I derived that I needed my drive pulley to be 1.2 inches. After some more CAD work, the pulleys were done and ready to be 3D printed. And last but not least, I whipped up some quick little feet, which allow me to screw down the assemblies without crushing any of the circuit board or exposed solder joints on the underside. And with some TV magic, here's everything coming together in under 10 seconds. With the physical pieces complete, I installed and wired everything inside the Jukebox, keeping the aesthetics in mind as I went. All that was really left was the code to make everything work together. Here's how the software works. The Raspberry Pi was coded to act like a web server. This means that the Pi is set up to be able to serve web page files to any device that it connects to. Although a web server can be made to be accessible from anywhere in the world, I chose to make mine so that it was only available to devices connected to my home network. I couldn't come up with a single reason why I would want myself or anyone to be able to change the volume in my house while not actually at my house. But I could think of many reasons why that would not be a good idea. Every web server has its own internet address, much like the unique address of every home and business across the world. So by creating a home screen shortcut to the IP address of my server, I essentially created an app on my device without needing to go through any app approval process. So when I want to change the volume setting, I click the app on my device, which then connects to my Raspberry Pi and requests the web page. The Pi then sends the web page data back to my phone, which includes the current positions of each volume zone. As I move a slider up or down, my device sends that information back to the Raspberry Pi so it can then communicate with the servo motors and turn them to a new position, thereby changing the volume in that room. Besides just the sliders, I also added some preset buttons for some common slider position combinations. For example, I have an all-off button, which brings all 10 channel sliders to 0. I also have a morning preset button to start my day, which puts all the sliders throughout my entire house at a level of 2. Some other buttons include all -1, all +1, and of course, party mode. And as it turns out, I'm not the only one that loves these volume controls. Apparently my kids think I'm Alexa. Oh, there is one problem I forgot to mention. Being the caring, loving husband that I am, I gave my wife access to my app. Which sounds innocent enough, except that now we have these virtual volume wars where I turn the music up throughout the day and she likes to turn it down to a reasonable volume. So don't tell her, but I created some code that allows me to override her volume changes. This admin mode allows me to set specific volume levels, so even if she changes the levels, they slowly creep back to my preset after 60 seconds. Score 1 for Team Rob. All in all, the system works absolutely awesome. I've been using it for about 2 years now successfully with basically no problems at all. It's been a real game changer that no matter what I'm doing, no matter where I am in my house, that I can control the volume of the room that I'm in or any other room. Before we finish up, remember that one of the reasons that this design came to fruition was because I wanted to redesign the look of my jukebox. And although I did just that, the jukebox currently sits in a somewhat disheveled state. It's definitely lacking in an overall impressive appearance. The Rube Goldberg influenced volume controls are cool, but there's so much more that could be incorporated into this space. I did throw a monitor in there, but there's the whole square peg, round hole problem, and nothing seems to fit just right. So maybe a custom shaped screen or an internal projector, perhaps some cool lights or lighting effects that match the beat of the currently playing songs. Regardless, if you have some cool ideas that you think might make the overall appearance of the jukebox better, let me know in the comments down below. I do plan to make a future video documenting version 2.0 of the jukebox once I figure out all the aesthetics. If you're interested in making this or something similar, I put links down in the description below to all the code I use to write the software, both front end and server side. I also have all the 3D CAD models available for download, as well as a list of all the parts I used. It's all there and available for free if you're interested. Thanks for watching. Alright, let's take 3 takes of that. It's gotta be enough, right?